Okay, in example 2.22, we found dy dx when y is equal to 1 over x, or x times y equals 1. And now we're going to find the same derivative, but using the process of implicit differentiation, which is an application of the chain rule. And so with implicit differentiation, what we do is we take the derivative, or we apply the derivative to the entire equation, and any function that contains y, or any expression that contains y, you're thinking of as a function of x, and so you have to use the chain rule. So when I apply dy or d dx to this whole equation, I'm going to get the derivative of x times y. Well, that's going to require the product rule. So that's going to be d dx, that's the derivative of the first, times the second, plus, and now you're going to take the first times the derivative of the second, which is x times dy dx. And then I'm going to take the derivative of 1, but the derivative of 1 is 0. So again, that was because we have a product x times y, we apply the product rule, and it says that you take the derivative times the first times the second, plus the first times the derivative of the second. And now the derivative of x is just 1. So I get 1 times y plus x times, well, the derivative of y with respect to x is just dy dx. And then the derivative of 1 is 0. And then I'll subtract y, and I get x times dy dx equals negative y. And then I'll divide both sides by x to get dy dx by itself. So I have negative 1, or negative y over x is my derivative. And now what you have to do is remember that y, if x times y equals 1, then y is equal to 1 over x. And so when you plug this expression in here, you get that dy dx is negative 1 over x divided by x, so it's negative 1 over x squared. Okay, so that's using the fact that y was 1 over x. So this right here, if you plug in 1 over x, then you get this, that dy dx is negative 1 over x squared, which is exactly the same derivative that we found before. And now in this example, it was actually more work to find the derivative implicitly. But in the next few examples, you see that it's usually much faster if you use implicit differentiation than trying to solve for y.